Let's hunker down now for some 6. Section 6.
If you want to talk in the microphone, just talk in the microphone. Course 102, Section 6, Property Tax Math. You know, if you say that wrong, property math tax, you just like property math. Property. I need some property math, man. I gotta have it. It's property math. Sorry.
Do you want to talk in front of the microphone?
Learning objectives. At the conclusion of this section, students should be able to identify the typical units of measurement. Identify the typical units of measure applicable in measuring land or improvement area. Explain the calculation and appraisal uses of ratios and percentages. Calculate basic appraisal problems. Units of measure. Front foot, used when the amount of the property's value is significantly influenced by frontage to a road, highway, or other feature. Square foot, used when the value is based on size. Per acre, typically used on rural or large tracts. Vara may be found in old deeds and ownership records. See equivalent measures table next page for additional units of measure. So, unit of measure, foot, is 12 inches linear, and its area is square foot is equal to 144 square inches. Unit of measure, yard, is 36 linear inches, or 36 inches linear. Its area is square yard. There are 9 square feet. Does that make sense?
Yeah.
Okay, a rod is 16.5 feet linear. There's 30.25 square yards, or 0.006 of an acre. Vara, which is 33 1/3 inches linear. Its area is a square vara, which is equal to 7.7 square feet. Unit of measure, acre, is not available in a linear measurement. And then the area is 43,560 square feet, 4,840 square yards, and 5,645.4 square varas. Labor is not available for a linear measurement, and then the area is 1,000 square varas, or 177.1 acres. A league, there's not a linear measurement, and the area, is that right? Yeah, area is 5,000 square varas, or 4,428.4 acres. A section, there's not a linear measurement. The area is 640 acres, 1,900.8 square varas, or 1 square mile. A mile has 5,280 feet, 1,760 yards, and 1,900.8 varas. That's linear. The area is 1 square mile, 27,878,400 square feet, or 3,097,600 square yards.
They'll probably ask us a stupid question like there on the test.
Well, at least there ain't no cubits. So be calculating the area. The area of a square is base times height, or length times width.
And you can go down to the next one. Area of a rectangle. You don't have to do those numbers.
Okay. The area of a rectangle is base times height, or length times width. A parallelogram is a quadrilateral with 2 pairs of parallel sides. Squares and rectangles are parallelograms. The area of a parallelogram is base times height, or length times width. The area of a triangle is 1/2 times the base times the height, or 1/2 times base times height. A trapezoid is a quadrilateral with one pair of parallel sides. Find the area of a trapezoid. Average the parallel sides and multiply the average by the height. To find the average of the parallel sides, add them together and divide by 2. So, or you're going to multiply by half to find the sides. So A equals 1/2 times B plus B times H, where B plus B are your sides, right?
Yeah, your parallel sides.
Yeah, parallel sides. See, I learned it with P's. The radius of a circle is a line segment beginning at the center of the circle and ending at the point of the circle. The area of a circle is pi times the radius squared. Pi is approximately 3.1416 rounded to 4 decimals. So your area is equal to pi times r, or pi r squared. Sector of a circle. There's really not any information here.
Except there is in the paragraph.
Oh, okay. A sector of a circle is a fraction of the circle. Think of it as a slice of pizza. When calculating the area of a sector, think about finding the area of a fraction of the circle or the area of the slice of pizza. To find the area of a slice of a sector of a circle, of a slice of a pizza, first determine the angle of the sector. Divide the angle by 360 to determine the fraction of the circle. Multiply the fraction by the total area of the circle. Example, in the circle above the angle, that's a 0.
I don't think so. I think that stands for something else, but I don't know what it stands for.
Yeah, I've never seen that.
Yeah.
Anyways, in the circle above that,
a sector, probably.
Probably it is sector. So the angle of a sector is equal to 80 degrees. If the radius is 5 foot, find the area of the sector. So angle of a sector is equal to 80 degrees. So 80 degrees times 360 degrees equals... sorry. I told you I have contacts now.
I know, but that doesn't look like no X.
Well, not to you it doesn't. So 80 degrees divided by 360 equals 0.2222 fraction of a circle, less the rounded to, or is that less or no?
Yeah.
Rounded to 4 decimals.
Yeah. Oh, yeah. No, it's not less.
It's not less, it's just a dash. So 3.1416 times 5 foot equals 78.54 square feet, the area of total circle. 0.2222 times 78.54 equals 17.4516 square feet, area of a sector of circle, rounded to 4 decimal places. Volume, multiply the area of the base of the structure by the height. To find the volume of a building, first calculate the surface area of the base, ground floor, using the formulas previously discussed. Square, rectangle, parallelogram, trapezoid, triangle, and circle. Next, take the calculated area from step 1 and multiply by the height of the building. Percentages and ratios. A ratio is a way to compare quantities. For example, use ratios to compare land to property value, which is discussed in number 3 below. Ratios can be written 3 ways: 1:5, or 1/5, or written out 1:5. That's a 1:5, not a Bible verse. A diggledy-dot. A percent is 1 part in 100. Percentages are always expressed on the basis of percent hundred. 0.20, or rather 20% means 20 per 100, right? Okay. For example, if 20% of homes sold for more than $100,000, then 20 out of every 100 homes sold for over $100,000. Building to property ratio. Building value divided by total value equals ratio. Example, a building is valued at $75,000. The total value of the property is $100,000. To find building to property ratio, divide 75,000 by 100,000. 75,000 divided by 100,000 equals 0.75 or 75%. The building to property ratio could be described as 75%.
Or 3 to 4, or whatever. Okay.
So land to property ratio. Land divided by total property value. Example, the land value of a property is $25,000. The total property value is $100,000. To find land to property ratio, divide 25,000 by 100,000. 25,000 divided by 100,000 equals 0.25 or 25%. The land to property ratio could be described as 25%. Ratios may be described as follows. A land to property ratio is 1 to 5. A land to property ratio of 1 to 5 means the property has 5 total parts of which the land is 1 part. So if the total property value is $100,000, then 100,000 divided by 5 equals $20,000. Each part is $20,000. Land is 1 part, therefore, comma, therefore the land value is $20,000. The other 4 parts are the improvement or building. The improvement/building would be valued at $80,000. 4 times 20,000. The 2 parts added together must equal the whole. If the land property value is 1 to 5, the building to property ratio must be 4 to 5. Typical appraisal calculations. Land value estimate. Allocation. A method used to estimate land value by using a typical ratio of land value to total property value. The method for using the ratio is as follows. The typical land to property ratio for a subdivision is 20%. A property recently sold for total sales price of $140,000. The appraiser using the allocation method could take $140,000 times 20% equals $28,000. Based on the typical ratio for this subdivision, the land value could be estimated at $28,000. If the land is estimated to be $28,000, then the building value estimate would have to be $112,000. The land ratio is 20% and the building to property ratio must be 80%. Remember, the 2 parts must equal the whole. Abstraction. A method used to estimate land value by deducting the value of the improvement from the total value. An appraiser could estimate the value of the improvement and subtract that value from the total value. The remaining value would be the land. Estimating the value of improvement by using the RCNLD was discussed earlier in cost approach. For example, if a property recently sold for $150,000, the total value is $150,000. Appraising using the RCNLD method from the cost approach would determine the estimated value of the improvement to be $130,000. Simply subtract the improvement value from the total value. $150,000 less $130,000 equals $20,000. The land component would be $20,000 in this example. Once again, the 2 parts must equal the whole. Replacement cost calculation. This method was introduced in the cost approach to value. Appraisers need to be able to consider and add value for property characteristics that are not included in the base cost tables. Example, estimate the cost of a single-family home that has 1,200 square feet of living area. The appraisal district's cost tables for that particular class of home indicate a cost of $75 per square foot. The subject property has 2 additional features, half baths and fireplace, that are not included in the typical cost for the class or quality of property. Appraisers must account for these additional features in the estimate. 1,200 times 75 equals 90,000. Estimate cost of half a bathroom is equal to $3,000. Estimated cost of fireplace is $2,500. So 90,000 plus 3,000 plus 2,500 equals 95,500. Total RCN of the property is 95,500. Percent good calculation. Percent good is another method to describe depreciation. Instead of describing the loss in value as a negative, percent good describes how much of the life the property has remaining. Property described as having 20% depreciation could be described as 80% good. The amount of depreciation in the percent good should total 100%. For example, the replacement cost new, the RCN, for a property was calculated to be $120,000, and the percent good is 80%. The improvement value would be calculated by multiplying the RCN by 80%. The resulting value is the RCNLD, 120,000 times 80%, equals 96,000. To test this calculation, subtract 20% depreciation from 120,000, and the answer should equal RCNLD. 120,000 times 20% equals 24,000. 120,000 less 24,000 equals 96,000. By using percent good method, one step can be eliminated. Time adjustment. Appraisers always adjust comparable sales to the date of appraisal. The appraisal district's date of appraisal is January 1st of each year, and if necessary, appraisers adjust sales to match that date. For example, a property sold for $150,000 6 months prior to the date of appraisal. The analysis of the market indicates properties are appreciating at a rate of 1% per month. Determine the sales price of the comparable sale as of the date of appraisal. 6 months times 1% per month equals a 6% increase. Take the sale price of $150,000 times 6% equals $9,000, and add the $9,000 to the original sale price and estimate the comparable would have sold for $159,000 as of the date of appraisal. Appraisers can use this technique to adjust sales for an appreciating or depreciating market. Went too far. Sorry, my finger got too heavy. Estimate the amount of time between two dates. Time is typically described in months. When the date is noted only as a month and a year, appraisers consider the date to be the first day of the month. For example, if an appraiser was given the date 4/2018 and 9/2018, he or she would assume the full dates to be 4/1/2018 and 9/1/2018. The month of April would be included in the time frame because the bulk of time occurs after April 1st. The month of September would not be included because the bulk of time occurs before September 1st. The amount of time would be 5 months, including April, May, June, July, and August. If the appraiser is given the exact month, date, and year, the rule is to determine if the bulk month is inside the time frame. If the first date falls between the 1st and the 15th, then the month would count. If the second date falls between the 16th and the last day of the month, then the month would count. Example. Using the dates 4/11/12 and 10/21/12, calculate the number of months between the two dates. Because the first date is 4/11/12, April would count because the 11th is between the 1st and the 15th. October would count because the 21st is between the 16th and the last day of the month. Therefore, the number of months would be 7. Calculating rates of change. Appraisers should be able to calculate the rate of appreciation or depreciation in the market. To accomplish this task, the appraiser may look at sales data that contains properties which have sold twice with no changes in the property characteristics. The difference between the two sales will allow the appraiser to determine how time impacted these sales prices. For example, a property sold on May 5th, 2018 for $160,000 and sold a second time in November 2018 for $169,000. The property characteristics did not change between the two dates. An appraiser would take the difference between the two sale prices, $9,600, and divide by the earliest sale price of $160,000 to get 0.06 or 6%. This is the overall percent of change. The rate of change needs to be described as a rate of change per month. Divide the percent of change by the number of months, 6, see estimating amount of time between two dates above. 6% divided by 6 months equals 1% per month. By gathering enough of this type of data, an appraiser can estimate a rate of change for a particular property type in a specific market. Calculating value. Typical units of measure. Appraisers typically describe value by using various units of measure depending on the property type. For example, appraisers generally describe residential property by using square foot as the unit of measure. A home sold for $160,000 with 2,000 square feet of living area could be described as having a sale price of $80 per square foot. That would be calculated by dividing the sales price by the amount of square feet. $160,000 divided by 2,000 equals $80. When dealing with commercial property, there are multiple ways to look at sales prices. One method is by describing the sale price by gross or total building area. For example, a building with 8,500 square feet of gross building area sold for $500,000. Divide the sale price by the square feet to determine the gross area per square foot. 500,000 divided by 8,500 equals $58.82 per square foot of gross area. Another method is to describe the net rentable area per square foot. If the same building had 8,000 square feet of net rentable area, then divide the sale price by the net rentable area to determine if the net rentable area per square foot. 500,000 divided by 8,000 equals $62.50 per square foot of rentable area. The same concept can be used to describe sales by the number of beds, rooms, or whatever unit the appraiser may calculate. Apartments would be sale price divided by the number of rentable units. Golf courses are described as sale price per hole. Nursing homes are described as per bed. Number 2, gross rent multipliers. Gross rent multipliers are calculated based on annual rent as it relates to the sales price. Appraisers could take the property that sold and divide the sale price by the annual rent. The result is referred to as the GRM, or gross rent multiplier. For example, a property that sold for $280,000 has a gross rent of $2,600 per month. $2,600 times 12 equals $31,200 gross annual rent. Divide the sale price by the gross annual rent. $280,000 divided by $31,200 equals 8.97 GRM. If the appraiser could gather enough data to calculate several GRMs, he or she could possibly see trends in groups or types of properties. 3 approaches. Cost approach calculation. The subject property has 1,800 square feet of living area. The property has an enclosed porch with 210 square feet and a 440 square foot garage. The site value is $8,000. The cost schedule indicates a cost of $75 per square foot of living area, $40 per square foot for the garage, and $12 per square foot for the enclosed porch. An appraiser estimates the percent good to be 85%. What is the estimate of total value for this property? 1,800 times 75 equals $135,000. 440 times 40 equals 17,600. 210 times 12 equals 2,520. RCN is $155,120. 155,120 times 85% good is equal to 131,852 plus a land value of 8,000. 131,852 plus 8,000 equals 139,852. Sales comparison approach calculation. The subject property is a hotel with 180 rooms. An analysis of the market data of similar hotels that recently sold indicates a value of $9,500 per room. What is the market value estimate for this property? 180 times 9,500 equals $1,710,000. Number 3, income approach calculation. The subject property has an annual effective gross income of $68,000. The annual expenses are $31,000. The cap rate for this type of property is 12%. What is the capitalized value estimate for this property? $68,000 minus $31,000 equals $37,000. $37,000 equals the NOI. So $37,000 divided by 12% is equal to $308,333.